How's it going, everyone? I'm Driftwood. Welcome back to Learning GameMaker Studio 2. In this episode, I'm going to show you how to design the logic for a new type of enemy, an enemy that doesn't actually go kamekazi for your ship, but instead it'll get within a certain distance and fire back at your ship with a different laser. So let's go ahead and jump into an example of what I'm talking about. I also added a separate scene that gives a little bit of instructions to the player. This is an ugly ass menu and will be remade, but for now it's an example of what you might want to do before you start the player in your game. At the beginning, we said, the title of the game, the splash screen or whatever, and then maybe an icon of your studio. And then when you hit enter to go to the next scene, you'll give some instructions. It could be just a simple black screen with some text on it. You don't actually have to make an image in Photoshop for this, but you might want to make it look decent. This doesn't look very great. This is just a quick fix for what I needed it to do. So this is WASD to move, escape to pause, left click will fire your lasers, right click will launch bombs, and then the same, we're reusing as many assets as we can to just keep the size of the project down. So we're doing the same object, and the way that I've made this work is I'm making the code, instead of go to room main, we're going to go to room next in the code. So if I place these rooms in order, it'll go from the title to the tutorial, because this is going to the next room, and then if we hit it again, this will go to the main scene. So we hit it again, press M to mute. So in this tutorial, we're going to take a look at this ship right here. So you've got this bigger ship. We've got these little frigates that come at us and they try to kamikaze, and the next ship is a cruiser. He's not trying to kamikaze at you. He's trying to get within range and then fire a laser at you. Now his laser has a timer on it, and his timer, okay, we died there, but you can see he was coming at us, and he would kind of like go at us in a certain direction and then fire a laser, and then as he was recharging, he wouldn't try to attack the player. He would just keep going in his trajectory until his timer was ready. Then he would come back at the player when he was fully charged, ready to shoot another laser. And that's a timer that you can set up yourself to, I'll show you how to make it as long as you want it to be. It could be fire every second. I have him set into 180 frames at 60 frames per second. So he's going to fire a laser at us every 3 seconds approximately. So to do this, right at the top, we're going to make a new enemy. To do this, you can actually duplicate your current sprites and objects. So at the top, let's make the graphics for everything we're going to need here. We're going to take our sprite frigate and duplicate it, or whatever you want. You can create a new one, but basically I just made the cruiser by adding some extra pixels, like for extra armor. I added another bit of blaster. If we animate this, you can not blaster, but like thrusters. So it's got a little bit more thrusting power, it seems like. Even though it's moving slower, it's a bigger ship. So I just added a little bit of stuff to it. Nothing fancy. You make it look however you want. You may not even be making a space shooter game. The logic will apply. You can make it any type of game you want, really. So we've got the sprites for that. I think that's the only actual sprite we need, because the rest of the stuff is reusing the other assets. So we're going to be making new objects, but once again, you can duplicate your other ship if you don't already have it. We're going to go over everything. So in the cruiser, on the create step, we're scaling it to 1, which you don't have to do. If you want to scale it, it's better to make a bigger sprite and scale it down than a smaller sprite and scale it up. I'm keeping this here in case I want to change the size later on, but you don't actually need that code at all, because it automatically X scale and Y scale to 1 by default. So we're giving it some temporary variable, or some, not temporary, we're giving it some variables that we can manipulate later. So we're giving it a max HP of double that of our smaller enemy, so it's a little bit harder to kill. So we're setting his HP to its max HP. You can get past all of that if you want to make it even simpler and just go HP equals 200. We're setting the speed to a random value between the max number of 1 and 1.5. So the ship will never be slower than 1 pixel per frame, but it'll never be faster than 1.5 pixels per frame. You can change that around however you want using the max and the random functions. And we're setting another thing, cruiser laser cooldown. Now this one needs something different from the frigate, because the frigates don't have lasers, so they don't need the variable of the laser cooldown. And we're going to be specific with how we name our variables so that it's very clear what that variable is. We're not going to write like CLS or CLC, because later on you're going to find when you have like 10 things, you're going to be, what was that one? I forgot what that one was. Just, it may look like the code is longer, but it'll be more clear what it actually is. Unless you want to add note tags in which you're still typing the code, so, you know, however you want to do it, really. I'm calling it cruiser laser cooldown. I'm using a camel case JavaScript thing that I do when I'm doing JavaScript stuff too, where I start with the lowercase and then I don't use underscores unless I'm calling it the first thing. I have my own naming convention. You probably have your own as well. So I go what it is, object, a sprite, something, and then underscore, and then I camel case everything else because it's just less characters between this. It would be it's actually 2 characters less, and it's already a long name. So cruiser, capital L on laser, capital C on cooldown. Remember, things are cap sensitive when you're referencing them. So we're setting that to 0, so right off the bat, it's ready to fire. On the step event, we're going to say a little bit more logic than the frigate. So we'll go over it. We're going to nest a couple of if conditions, but we're going to use else handlers as well. So we're going to say if the instance exists, object player, which is something we've seen before. So it's basically checking to see if the player is there. If the player is on the map, then we're going to say if, another conditional statement, if the distance to point, I don't know if we covered this yet, but if you middle click it with the mouse, you get some more description on all of these things. So you could type them out and then look at the help file if anything confuses you. So if the distance to the point, we're looking for an X and a Y. So if we're just looking for a location. So if the distance to this location, in which location we're referencing the X value of the player and the Y value of the player, is greater than or equal to 100, then we're going to do the next thing. So hopefully that makes sense. When you're referencing another a variable or a value that's in another object, you have to call that object right here. So obj_player, because that's what I called it right there. Dot X, so we're saying player's X, player's Y. I'm sure you get that by now. We're gonna open up another brace for the next thing. So if the player's there and we're more than 100 pixels away from the player, we're going to do another thing, move towards point. I think we actually did this before. We're going to do the same thing. We're going to reference the player's X and Y value. So X, Y, and then we have to just specify how fast do we want it to go towards that object. So we're going to set it to the variable we created, speed, SPD, at the beginning. So we're setting our speed 1 to 1.5. So we're going to move towards the player, if it's there, and we're over 100 pixels from it, this fast. Easy to understand, right? But now, instead of another nested if condition, we're doing an else handler with a condition. So we're going to say else if, so that's saying if we're not greater than equal to 100, and the cruiser laser's cooldown is less than or equal to 0, that means we're ready to fire, our lasers are charged, then we're going to instance create layer, which I'm sure you know what that does. It calls another object onto the menu, onto the scene, onto the map. We're going to say, fill out all of the arguments here, X location, Y location. We're going to say create it where this X is. We're not having to reference another object because we're talking about the X and the Y location of this object. We're going to say on this layer, you can call whatever layer you want. I've created a layer, instance layer 2 for like things we create like bombs and effects and stuff like that, animations and such. And then we're going to say what object do we want to call. Well, right now you don't have this object created, but we're going to just reference, we're going to say it right here, we're going to type it out, and then we're going to create it afterwards. So we're going to say object underscore cruiser laser, because we have to make that laser as well. So right now just type that out, call it whatever you want, but we're going to have to make it and call the object exactly what we typed there. So then if we fire the laser, you know, we're creating the object, and the laser itself is going to have the logic to move towards the player and try to hit the player. We're going to say set the cooldown of the laser to 180. So we're going to say cruiser laser cooldown is 180. Now this is to say 3 seconds. If your game is going 60 frames per second, then every second 60 is going to tick away. If you do this at the end, which is we're going to get to, we have to find some way outside of this conditional to every step of every frame of the game reduce that cooldown by 1. So 60 cooldown steps every second. Okay, so once we've set our cooldown, we have another else handler, because if our distance to point is greater than equal to 100, and so basically if the instance exists, but we're close to the player, and our thing is on cooldown, then what do we want to happen in that case? Well, we're going to say this is a very simple way to do it. X equals X, Y equals Y. That's going to have the ship to just kind of like strafe away in its current direction. It's not going to change any it's not going to change its velocity. It's not going to change its angle. It's going to keep strafing. Like basically, it's going to shoot and run. It's going to shoot, and then once it's like close to the player and it's on cooldown, it's going to keep going, trying to get away from the player because it doesn't want to kamekaze the player. It wants to circle back around when its lasers are ready to fire and shoot at the player. So it's going to just keep going in its direction, in its trajectory, and then after its cooldown is in 3 seconds, it's going to whip back around and come back at the player again and try to shoot again. And then if it's close to the player and it's shot its laser, it's going to keep strafing in its direction. It may collide with the player, but it's not trying to collide with the player. So that's the logic for that. But we still have to design the laser. So after that, we're going to set the cooldown. Otherwise, it's going to fire the laser one time and never shoot again. So we have to say cruiser laser cooldown minus equals 1. This is shorthand for cruiser laser cooldown equals cruiser laser cooldown minus 1. So minus equals is just subtracting from that variable. And we're doing this every on the step phase outside of the conditionals. So no matter what is going on, the cooldown on the laser is being recharged. So every 3 seconds it's going to be able to fire if it's in range. Then what we're going to do, this is depending on how you drew your sprite. So you can see that my sprites for my player is pointing to the right. That means my direction is 0 and everything is kosher. But if your sprites are going to the left, now you're 0, we have to remember that 0 is default to the right. And then as we go 90, when we do 180, it's going to be defaulting to going to the left. So instead of drawing a sprite for every way the ship is going to be facing, we're just going to draw it once and we're going to spin it. We're going to change its angle depending on which direction it's moving. It makes sense to do it that way. Less resources. It's easier. But because it's facing left, we have to go image angle equals direction plus 180. Right? So that's the same as facing the opposite direction. So that's how you would rotate it. So we're changing its angle based on its direction, and if it was facing right, you wouldn't do the plus 180. Hopefully that makes sense, but because it's facing left on these sprites, we have to do plus 180 to get it to look. Otherwise, it's going to face right and be moving left. So hopefully that's clear. You can get around, like I said, one last time because it can be confusing. Just get rid of this if it's facing right, if your ships are facing right. So now we're going to do the code to see what items it drops and how to destroy it. So we're going to say, make a conditional on the step event. If the HP, and we're referencing its own variable, if its HP is less than or equal to 0, then we're going to create a temporary variable. Now this is a temporary variable because we're not referencing this object's loot drop variable anywhere else besides right here. This is going to use up less resources for the whole project. So we're going to say create a temporary variable, which will be just removed from memory after it's done with this condition. It's going to say create a temporary variable called loot drop and equal it to a random value between 0 and 100. So if you do random, we already talked about that. You just put in a number, it'll give you a variable, a float value from 0 to 100. So then we're going to say another conditional, if our loot drop, now we don't have to say var anymore because we're not actually creating another temporary variable. You only have to, you don't have to use var to reference it. You only have to use var to declare and like initialize it, right? So we've initialized it to this value, and every step, every time it goes through this, it'll give it a different value, especially if you randomize, which we've already talked about. So I've randomized on the status object. So we're saying if loot drop is greater than or equal to 25, which means basically 75% of the time it's going to drop minerals. Instance create layer on its own X, its own Y on the instance layer. This could actually be on instance layer 2, but it doesn't matter. Oh, excuse me. And we're going to do objects minerals because that's the coins, the gold coins. This is, you could actually call this, you could do whatever you want right here. If you wanted to drop something, you can just create a temporary random, check to see if it goes over a certain number, and based on that number, you can determine what percentage you want it to drop, and then just drop it. And it's just create layer. So then, we're going to say that that's its own condition, that's its own thing right here, the loot drop. But you're still going to do, so all of that is for the loot drop. These other two things are to actually remove it. So if its HP is less than or equal to 0, we're going to instance create layer on its own X, its own Y on layer 2, and object dust animation. That's just going to show an animation that it was destroyed. And we're going to do instance underscore destroy with no arguments. Will remove its, it will remove itself when it has no arguments. So it's going to destroy its own object. So If its HP goes to 0, it's going to roll a number. If the number is high enough, it'll give loot. It'll show an animation. It'll kill itself. Cool. So if that actually collides with the player, we're going to do the same thing. So with other, instance create layer. Now this XY is actually referencing the other object. So on the player, because we're colliding with the player, on the player's X and Y, we're going to show the ship collide damage pop-up, which is another thing for one of the previous tutorials to show if you want to show like -20 or whatever. We're going to, on that layer, we're going to draw that object, which will create text. And we're going to say obj_status.playerHealth. Wherever you're storing the player's health, you have to call that object and then dot the value that the player's health is, minus equals shorthand for itself minus this number. Whatever you want it to be for colliding, whatever you've set in your ship collide damage pop-up to be. You could also set that to a variable and reference it in that object as well. We've already talked about that. So then we're going to do instance create layer, the dust. So it's going to turn to dust, but this is not with the other. So itself is going to... it's going to do a damage pop-up on the player, but it's going to turn itself into dust, and it's going to destroy itself when it collides with the player. If it ever happens to get outside of the room, outside of the whole area, then it's just going to destroy itself. Now, this isn't outside of the viewport, so it may be off the screen, and it'll still, if you're zoomed in, right, it could still be there and fire at you if it's in range. But if it gets completely off of the map, the whole map, then it will destroy itself. That's just to eliminate any possible memory leaks if too many objects get off. We're going to do that with all the objects. If they get outside the room, just destroy itself. Now we're going to do the draw, and since we're calling the draw, every time you call the draw, you have to draw self, otherwise it won't show its own sprite. We're going to say if HP is less than its max HP, then we're going to draw the health bar. Now this is something we already talked about on enemy health bars tutorial. It's a very, very simple way to show how much HP it's got left. If it's got full HP, it won't show it. It's just going to show the sprite. But if it has less HP than its full HP, it's going to draw a health bar, built-in function. You can middle click it to learn more. We're going to give it two locations, an X1 and Y1 to draw a box. We're going to give it a variable value that's going to give up to 100%. So HP divided by max HP times 100. We're going to give it some colors for the background. Give it some colors for when it's low on life. Some colors for when it's maxed out on life. If we want to show the direction that the bar is filling from right to left, we're going to say if you want to show the background true, if you want to show the border true, these are Boolean values. This will go from 0 to 360. These are Boolean values, and you can use C_color, and you can middle click that to see a whole list of colors. You can actually use your own color if you want to. So that's it for the cruiser. Right, that's the whole logic for the ship, but the laser still doesn't know what to do. Remember on the step event we were doing create object cruiser laser if it can fire. So that laser isn't there yet. So what we're going to do is you can just duplicate the laser or just create it from scratch, create a new object, give it whatever sprite you want. On the create event, we're going to scale it down a little bit. You could just make it an 8x8 or whatever you want. Scaling completely optional, up to you. You can totally skip it. But what we're going to use, since we're not using physics, we can use direction, speed, and everything. So we're going to do direction equal point direction, XY, the object player's X, and the object player's Y. So this is going to say create a number to determine 0 to 360 based on these 2 points in the game. So depending on point A and point B, you know, X1, Y1, and X2, Y2, create an angle based on those 2 points. So then we're going to say the direction equals itself, but we're also going to add a random value to give or take like some variance on, you know, how the ship turns while it's shooting. So it's not a straight line. It could be 5 below or 5 above on the angle. So it'll, instead of shooting a straight line like that, it can go 5 up or 5 down, and then, you know, you can change this value to whatever you want. You could also get rid of it if you don't want to have it. You want it to be a direct shot, like a super precise laser. Get rid of that point. We're going to give it the speed. Originally I gave this 8, but then it's kind of hard to dodge it. So this, you give it a speed, it's going to move this many pixels per frame every time. So I'm just saying 4. It's nice, slow, it's easy to dodge. You can make that higher if you want it to be harder. We're also going to set the laser image angle equals direction. Now, because this is a straight like laser like this, it doesn't matter what, you don't have to give it any value. If it was like a laser that looks different, coming right to left or left to right, you might need to add 180 to it or add 90 to it. You can add up to 360 to the image angle equals direction plus whatever to give the angle, to make it look like it'll fit right. So for me, because it's left or right, it doesn't matter. It'll look the same going both directions. So image angle, image_angle equals direction. So when it collides with the player, we're going to say with other So on the player, obj underscore status dot player minus equals 10. So even though we're referencing the player, I'm storing the values of the player's health on another object. So I have to reference that object even when we're using with other. So take away 10 from the health. This could actually be outside of the with other thing. That doesn't need to be inside here. But what does need to be inside here, instance create layer XY instance layer 2 cruiser laser damage pop-up if you're using the damage pop-ups. Now the reason why this needs to be here because we want the damage pop-up to be on the player. We don't want the damage pop-up to be on the laser itself, right? So we need to reference the X and the Y of the player. So when we collide with the player with other, create this using the player's X, the player's Y on whatever layer you want and whatever object you want to call for the damage pop-up. Then we're going to, outside of this with other, instance create layer, you know, XY of its own self, wherever the laser was when this happened, when it collided with the player. Create another object called object hit, which is just an animation, show an animation for when it collided, and destroy the laser. That's all that happens. So when the laser gets outside of the room, especially with bullets and things that you do as projectiles, you need to do this one. If it gets outside the room, you add event, collision, or no, other outside room, instance destroy. That way it'll kill itself and it won't eat up a bunch of memory just because you shot 1,000 lasers outside the room. They're not traveling to infinity, they're being destroyed. So that's it for that. If you want to do the laser, the damage pop-up, we'll take a look at that real quick, but this is something you could have already figured out. Cruiser laser damage pop-up if you've done the other tutorial. So all this really needs is image alpha equals image alpha minus 0.03 or whatever you want to use for to determine when you destroy it. Like before in the other tutorial, I was trying to do a timer, an alarm right here on the step, which is resetting at every frame, so it didn't work. But if you would have done the alarm 0 here, you could have added alarm and done this completely different. So I'm only using image alpha, which isn't affecting the sprite at all because it's not drawing a sprite. So this is just an invisible way to determine how long I want the laser, the damage pop-up to last. So we're saying x equals x plus 0.05 and y equals y minus 0.15. That's going to make it scroll up and to the right a little bit as the damage pop-up happens, so it doesn't just stick on the map. And it eventually gets destroyed by using this if image alpha is below equal or less than or equal to 0. But like I said, you could just do another way to do this is just do alarm 0 equals however long you want it to last, a second, and then you would go add alarm 0, and then you would just go instance underscore destroy. And that means on this, when the laser is, or when the damage pop-up is created, the alarm goes off, and then every frame it'll tick away at that. So in 1 second, the alarm will actually trigger and destroy itself. So you can use this conditional way to destroy it, or you can use an alarm. Both will work fine. I'll actually just comment this out. Make sure you do the alarm on the create step. I made an error earlier where I was trying to do it on the step phase and it didn't work because it just won't work. And now this could stay here because it won't affect anything because we're not actually calling the alarm, so that doesn't even need to be messed with at all. So yeah, that's pretty much it for the logic on the cruiser. Hopefully this, oh, it's 22 minutes. Okay, this thing went on quite a while, but it's pretty simple once you figure it out. And next episode, we're going to talk about parent objects. Now, you may think, oh, this works fine. We could just create another object and do the same thing. But eventually, you're going to have a lot of redundant code. You're going to have a lot of enemies that are basically the same thing with different animations and different HP values and maybe a couple extra things. So we want to actually use parent and child object relationships to sort of to make it a lot cleaner in your code. So in the next episode, or coming up pretty soon, and maybe in a 2 or 3 episodes, we're going to talk about parent objects and how you can make one object be hold all the code for any object that's like that object. Hopefully that'll come out and you guys can come out soon and you guys can use that, because right now it looks okay, but eventually you're gonna have a lot of redundancy and you want to eliminate all possible redundancy, and parent objects are gonna let you do that. So thank you guys so much for watching. I'm sorry this tutorial went on a little bit long. I'm trying to make them as short, as brief as I can, but sometimes there's a lot of information to cover and I don't want to skip over things that somebody may have missed, because I want to make these tutorials modular so you don't have to see everyone to follow where I'm at. You can take this information and throw it into your game and everything. So thank you guys so much for watching. Subscribe to the channel if you're new here. I have lots of RPG Maker MV tutorials. I've got GameMaker Studio 2 tutorials over the next year. I plan to make a lot of GameMaker Studio 2 tutorials. So stay tuned for that and subscribe if you're interested in that. Yeah, thank you guys so much for watching. We'll see you guys in the next tutorial. Bye-bye.